All right, before you come to class this week, I want you to just listen to this little bit of video or watch the video, listen to the voice, whatever. We're going to talk about endocrine drugs this week, and it's important that you have in your skull how the endocrine system works. All right. It's a very elegant system. I think you're really going to appreciate it after we get into it. So let's do that now. So remember, the difference between the endocrine system and the exocrine system is that exocrine glands secrete their stuff through a duct. So salivary glands, sweat glands, the parotid glands all secrete their stuff through a duct. Those are exocrine glands. The endocrine glands, however, secrete their stuff, the hormones, into the bloodstream or into local tissues. And what I mean by that local tissue thing is, for instance, the hypothalamus. So the hypothalamus secretes its stuff into the tissue of the pituitary gland, which sits right down there. Okay, and those are the beginning of the endocrine system. The pineal gland is that gland that makes melatonin and helps you to go to sleep at night. We have the thyroid gland, which is responsible for metabolism. We have the parathyroids. Remember, the only thing that the parathyroids and the thyroid have in common is their location, right? Their blood supply. They live in the same neighborhood. That's it. The parathyroids are responsible for calcium metabolism, all right? They're not responsible for metabolic stuff like the thyroid is. We have the thymus gland, which pretty much shrivels up by the time you're born or shortly thereafter, but it's responsible for T cell formation and getting rid of a ridiculous percentage of the T cells that are formed and fail their test. The adrenal glands then are down on top of the kidneys. Again, the only thing they have in common with the kidneys is their location. They're just neighbors. They don't do any of the same stuff. They don't even play together. Well, a little bit with aldosterone, right? So aldosterone is secreted by the adrenals, and that has a direct effect on the kidney, but that's it. Then the pancreas is interesting because the pancreas is an endocrine gland that secretes a hormone that we talked about earlier, right? Insulin, and all the other ones that go along with that, GLP and yada, yada, yada. But it's also an exocrine gland, and it secretes all that exocrine stuff, right? Like amylase and lipase and those kind of things. Then we have the gonads. Remember saying that in elementary school? Everybody giggle. Well, gonads is just a way that we can say either ovaries or testes in one word, and we can figure out whether we mean ovaries or testes by the sex of the person. So those are the endocrine glands, and this is the slide that you really have to know about now. If I can get to it, here it is. So this is my easy guide to the endocrine system. All right. It starts with the hypothalamus up at the tippy top here. And the important thing about the hypothalamus is that that is how the endocrine system gets input from the CNS, right? Because the hypothalamus is part of the brain, and it's also part of the endocrine system. So this is how your endocrine system gets input from the CNS. And that's really important for things like metabolism, for things like cortisol secretion. Remember we talked in class about somebody who comes into the emergency room, they're nervous, they're having a heart attack, they get a cortisol bump. Well, how does that happen? Because of their anxiety, right? So remember that the hypothalamus provides input to the endocrine system from the CNS. And this is where the releasing hormones are produced, like TRH. Then that secretion goes downhill to the to the pituitary gland, and at the pituitary gland, that's where the tropic hormones are produced, and then they go to the target gland, whether that's the thyroid or the adrenals or the gonads or the pineal gland or whatever the other gland is. That's the target gland. All right. Now, when there's a problem with the endocrine system target organ or target gland, then we call that a primary endocrine problem. So for instance, if your thyroid is broken, then we call that a primary hypothyroid or hyperthyroidism, because it's the thyroid itself that's broken. But there are secondary endocrine problems too, and this is caused by the hypothalamus and or the pituitary gland. So if your pituitary gland is broken, that will have an effect on the target gland at the end, but it's not because the target gland is broken. It's because you're not getting enough stuff from either the hypothalamus or the pituitary gland. So how does this all work? Well, the first thing that happens is that there's a positive feedback that happens when the hypothalamus releases its releasing hormone, and that gets to the pituitary gland. Then the pituitary gland produces its hormone, the tropic hormone, that gets secreted into the bloodstream and gets to the target gland, for instance, the thyroid gland. All right. And if this works perfectly, then the hypothalamus produces the TRH, and then the pituitary gland produces TSH, and then the TSH gets to the target gland, that is the thyroid, and the thyroid picks it up and says, all right, I'm supposed to make more, and so I'll do that now. And then the hypothalamus makes more, and it gets to the pituitary and it makes more, and it gets to the target gland and it makes more thyroid hormone. And then it just keeps on going like that forever, right? Well, what's to keep it from producing too much thyroid hormone? Well, that's where the negative feedback loop comes in. And this is where the elegance of the system, of the endocrine system, comes in. Because without a negative feedback loop, this positive feedback loop would just keep giving more and more and more thyroid hormone, right? The only way to control that is to decrease the amount of releasing hormone, TRH, or decreasing the amount of tropic hormone, or TSH. But what's going to tell it to do that? There's not enough input from the brain to tell the hypothalamus to decrease the secretion of TRH. So what we need is a negative feedback loop. And that starts with the presence of the thyroid hormone going to the pituitary, and the pituitary sensing that there's a sufficient amount of thyroid hormone circulating in the blood. Similarly, that thyroid hormone is picked up by the hypothalamus that senses that there's plenty of thyroid hormone circulating in the blood. And that normal negative feedback loop, shown here with these grayish green, kind of a gross color, arrows. These are the negative feedback loops. Okay? So again, the hypothalamus starts everything, produces the TRH, gets to the pituitary gland, the pituitary secretes TSH, that gets to the target gland down here, which is the thyroid in this case, and the thyroid makes thyroid hormone, or T3, T4 is the other way to say that. And then, in order to balance this, the T3 and T4 will be sensed by the pituitary gland, which will slow down the production of TSH. And there's a negative feedback loop that tells the hypothalamus, or the hypothalamus senses that there's plenty of T3 and T4 circulating, so it doesn't secrete as much of the stuff in the hypothalamus, all right, the TRH. Now, very briefly, let's just pretend that the pituitary gland is broken. What's going to happen then? Well, the hypothalamus is going to secrete TRH. It's going to get to the pituitary. It's going to sense the TRH, and the pituitary gland is going to make TSH. And then that goes to the target gland, the thyroid, but the thyroid is broken. It's not making any T3 or T4. So what happens is there's no negative feedback loop. And now the hypothalamus, not sensing any T3 or T4, makes more TRH. And the TRH goes to the pituitary, and the pituitary now makes more TSH. And then it goes and tries to yell at the thyroid gland, the target gland here, but the thyroid is broken. It can't listen. It can't do what it's being told to. There's no negative feedback telling the hypothalamus and the pituitary to calm down. So again, the hypothalamus makes more TRH, and the pituitary gland makes even more TSH. And now the thyroid gland is still broken, and so we get these really high levels of TSH and TRH when the thyroid gland is broken. So that's kind of weird, right? When you're hypothyroid, the TSH level and the TRH are high. You weren't expecting that, were you? Well, you probably were because you talked about it last semester. But it's weird. You just have to memorize that those are opposite, right? When the primary endocrine disorder is hypothyroidism, right? The primary disorder is with the thyroid. The thyroid is broken. And so the hypothalamus yells at the pituitary, you got to make more TSH. And the pituitary yells at the thyroid gland, you got to make more T3 and T4. And the pituitary gland gets continues to yell, but the thyroid gland doesn't hear it. It can't do anything about it. It's broken. All right? So that's what I want you to know before you come to class. I will see you when you get there.